So today's presentation is based on a large forecasting and replenishment project that SAS Poland is currently implementing at Rossmann in Poland. Rossmann is probably a brand I don't need to introduce much. This is an European drugstore chain. The home market is Germany. However, the company expanded in several markets, including Poland, and they also operate in Czechia. I don't think they are not present in Slovakia. So in Poland, Rossmann is the market leader. They have over 1,500 stores. It's definitely the biggest, the largest drugstore chain in Poland. And Rossmann operates inside the network many different formats. The stores are quite different and range from quite small neighborhood drugstores to really large stores that are located in shopping centers. And depending on the format, the stores have between the stores carry between 8,000 and 20,000 items. So it's the network, the formats are quite diverse. And the project scope includes demand forecasting, that is generating forecasts at the store and item level, and also automatic store replenishment, where we create forecasts that where we create optimal store orders that are based on those forecasts. We have already completed the first two parts of the project, and we are currently working on the supplier order generation part. So let's move to the business objectives of the customer. So why did the customer start a project with us? So there were many reasons. However, the most important were the business objective that the customer wanted to achieve. So Rossmann wanted first to improve forecast quality over the existing system. And this is more or less a standard requirement for this type of project. Why is that? Because this is really important and directly leads to a better monetary outcome, because an increase in improvement in forecast quality more or less directly translates into an increase of in-store product availability that leads to higher sales and better margin. Also important is that when you have better quality forecast, you can carry less inventory. So at the end of the day, you have better capital utilization. However, in the current economic climate where capital is not that expensive, the second objective is maybe not as much important as the first one, that leads into an increase in sales. Besides those core business objectives, Rossmann also expects from the project to achieve some operational improvement. This is because the current process is very labor intensive, and it involves a lot of manual work with forecast and order overrides. So this is an area that Rossmann seeks improvement. Finally, the third main objective of the customer is a technical one. The existing system had some performance scalability problems and was quite difficult to maintain. So the customer wanted to be sure that the new implementation will scale well. Let's move now to the first part of the project. Given that Rossmann has well over 1,000 stores and the stores carry up to 20,000 items per store, we are talking about millions, really millions series to be forecasted. So this is really an exercise in forecasting at scale. The we are forecasting at the lowest level, that is on the article by store by day level, and the forecast horizon is 4 months. The forecasts are used in several business processes at Rossmann. So obviously the most important one is to generate reliable store replenishment orders. This is, let's say, the operational process, the main operational process. However, those demand forecasts are also used for store labor planning, because we need to know how much labor do you need to have in a store to unload the big delivery. So this is really helpful for store labor planning. And also, similarly, these demand forecasts are used to capacity planning in warehouses. So these were the core processes. This slide presents a very simplified overview of the main operational process as implemented at Rossmann. The first step is performing cleansing of the data that have been imported from the source system. So we interface with some ERP system to get the sales data, to get the stock data. We need to get the planogram data from a planogram system. We need to import work schedules and so on. So we interface with a lot of different source systems. And then we need to assess and improve the quality of the data. We check the data for common problems, and if we find any of those problems, we try to fix them. Once the data are in shape, we move to the second step. Here, in that step, we generate features, that is, explanatory variables that will be used by the machine learning models. Those models are used in the forecast, in the next step, in the forecast generation step. So we use machine learning, to be specific, gradient boosting, to generate a demand forecast. And once the forecasts are generated, we move to the next step, which may include some overrides by business experts. This step is necessary because sometimes business users have external knowledge that is not present in the source data. So they use this possibility to influence the final forecast. Once we have the final forecast, those forecasts are used to drive the replenishment process. So based on those forecasts, based on stock at hand, based on the various parameters like lead times, expected service level, and so on, we calculate what optimal store orders. Given that the process is quite complex, we also include a monitoring step in the process. So if we find any problems, be it a technical problem or a business problem with the process, we report them. We send business users some alerts, and business users can react accordingly. They can also use some report to analyze the incoming data and the results we produce in the system. The complete process is implemented in SaaS using our new VIA platform. This is an enterprise-ready in-memory platform. So let's go more into the details. So as I already said, the first process is data preprocessing. So we verify the data quality and we check for problems that are typical for retail data. First, we check for out of stocks. That is, cases where a store runs out of an item because of high demand. In that case, if a stock out occurs, sales data do not reflect true demand because some demand could be not met due to this out of stock. So we need to identify those situations and we mark those out of stocks in the data so we can use those indicators in our demand models. The second issue we check for are outliers. Outliers understood here as atypical large transactions. So when we first received the data from Rossmann, we have seen not many, but quite a few strange spikes in the data. So for example, you have a razor that maybe sells for five items in the week, and suddenly you have a day where it sold maybe 100, maybe 200 items. What happened? We analyzed the data, and actually inside those data we didn't find any answer, and we need to review the detailed transactional data. And there it turned out that some institutional customers were simply buying at Rossmann. For example, a nursing home was buying large quantity of razors, and this is why we have seen those spikes. Those spikes typically are not standard demand because they need to be announced in advance. So we remove those spikes from the data. The last of the, let's say, more important issue we try to identify is fixed is the truncation of data. You have to keep in mind that the process we are delivering for Rossmann is an core business process, is operational. So you need the results day by day. And sometimes it happens that not all stores provide all the data they should have provided. So we might not receive some sales data or stock data from one or a few stores. So in such case, we still need to provide forecasts and we still need to provide orders for that store. So we need to verify, okay, we didn't receive data from that store. So for example, we need to use forecasts instead of the real data, or we need to use a stock forecast instead of the real stock. So you have to keep in mind that because of the operational character of the process, there is a lot of ETL work to make it happen. So going to the next steps, when the data are cleaned up and we can move to feature generation to generate the variables that drive the demand forecast. And here we use many different features. We build features based on the core product attribute, like product ID, product graph, the complete product hierarchy. Obviously, we need sales history, and we also use a very, very complex and comprehensive set of calendar variables that include a lot of information on special days like Valentine's, Mother's Day, information on holidays, be it national holidays, but also school holidays. Information, also we include information that is based on those calendar variables. So for example, we include information that, for example, a day is a bridge day between two holidays, or a day is the first working day after a holiday. So this is static information, and we use it to try to describe the historical demand. Obviously, we need to include prices, regular prices and promotional prices, and we also include planogram information. A planogram describes the location of end items on store shelves, and this is really important in the context of retail, because sometimes when you see nothing changes, the price is the same, but only an item moves from the lowest shelf to the top shelf, you can see even 15 or even 20% increase in sales. So the location of an item on the store shelf is really important for retail. And however, the most important features are related to marketing activity. And let's move to that part. So Rossmann is very active in the marketing space. They run a huge number of different promotions. And the simplest ones of those promotions are just price promotions, where you have just price reduction. That's it. Besides it, they run, for example, multi-item promotions that if you buy 2 items, you might get a third one free. So this type of multi-item promotion. However, there are also more. So these 2 cases are quite straightforward. However, they run also more complicated mechanisms. For example, they have promotions that they call category promotions. And when a category promotion is active, if you pick any items from a promoted category, you get any 2 items from a promoted category, you get the cheaper item free. So for example, if the promoted category is hair products and you pick an expensive shampoo and conditioner, you might get the cheaper item free. So this type of promotions gave us quite a lot of headache, because it was not that easy to model. Besides information promotions, we always try to include additional information, like information from flyers. So here what we have found out that especially if an item is listed on the first page or the back page of a flyer, it really drives sales. However, when an item is somewhere in the middle of the flyer, the sales typically aren't much affected. What we also include is information on store layout, because typically promotions go also with store layout changes. For you might have some additional stands that present the product. You might have impulse items presented next to the cashier desk. So those layout changes that support promotions also are included as features, and we found that those store layout features really have a large impact on sales, especially impulse items. The last category of variables that are used to model marketing activity are variables related to the e-commerce channel. Rossmann has a growing e-commerce channel, and we include, so here we include, but it's a mixed channel. So it's mostly click and collect. So you buy online, however, you pick up the items from the store. In here, they try to experiment with some promotions that are available only in the e-commerce channel, and we try to include that information also in the set of features that are used to drive the demand models. So going to the demand model, we estimate We don't use traditional time series technique like ARIMA or exponential smoothing to model demand. We used a quite new approach, that is machine learning techniques. To be specific, we use gradient boosting, and gradient boosting, a quite nice comprehensive implementation, is available in our platform. So we are using a SAS gradient boosting implementation. And what we do is that we estimate not models for a single series, but models for a related group of products. This has several advantages. It makes modeling much easier and much faster than typical time series modeling. We can use also of richer data sets because with classical modeling, it's not always easy to incorporate additional information. For example, a class that is very, very popular for traditional time series forecasting, that is exponential smoothing models, don't even allow for external predictors. So this the use of richer data produces significantly improved performance over the traditional approach. However, there are also some drawbacks. This is mainly it is that those models have lower explicability. So you get an answer, however, it's not that easy to deconstruct how did you obtain any given forecast. So let's discuss the models in more detail. So as I already said, models are estimated on product groups, and each product group, and in Rossmann, the size of the product group varies between a few dozens to even 5,000 in the case of makeup. So every product group is segmented into up to 5 strata, and we try to model the strata independently. The segmentation is based on total sales of any item in the whole network. For every strata, we estimated several models with slightly different formulations, and the final forecasts are obtained using from an ensemble. So we average the forecast from all models, and we found that this generates more stable, better forecasts. And we refresh the models every 2 days. Initially, we used a longer interval. However, due to the COVID situation, we decided to increase the frequency of the refresh cycle. And a feature that might interest you is that we used the auto-tune capability provided by SysVia to set the model hyperparameters. And auto-tune simply tries different combinations of hyperparameter, like the learning rate, like the number of trees, like the max depth of tree, and so on. It tries the different parameters to achieve the best possible forecasting model. And internally, it uses a genetic algorithm to search the hyperparameter grid. So this is quite nice feature that really speeds up modeling because you don't need to do it manually. This was what I presented so far was for regular demand products. However, there is also a class of products that has little or no sales history, that is new products. And new products are really important in retail, because you want to present the customer, you want to push the newest and most exciting products. So you need to have them in stores, and to have them in stores, you need to have good demand forecast for those products, because otherwise they will be not ordered to the stores. So our approach is more or less standard one for modeling new products, and we try simply to find a proxy product and we try to find it based on the product attributes of the new product. So we look at the core attributes, like, for example, hierarchy, the brand, because, for example, if a new toothpaste is introduced, we might use as a proxy for it and similar toothpaste from the same brand. We also analyze the price range, promotions. So if there is a promotion on a new item, we try always to find a similar item that was also on promotions in the past. For some items like makeup, like perfumes, we also use extended attributes from the e-commerce system. For example, color stand. Color is really important for makeup, for example. Once we find a proxy product, or more or less, we present our findings to the business experts, who verify the recommendations and sometimes make overrides. So this is the way new products are forecasted by us. But forecasting is not the end of the process. The final forecast, once we have them, are then fed into the replenishment part of the system. And here we automatically generate replenishment orders. And this approach of automatically generating orders is consistent with Rossmann's approach that uses a push model. So that means that a push model means that when a retailer uses push model, this means that more or less the stores have nothing to say regarding to their orders. They just receive them. This is in contrast with a pull model, where the store manager might receive some recommendation, however, has the final say in the order. The business objective for the replenishment process is to optimize, to maximize in-store product availability, because this is where the money is. You need to have merchandise in store. And those orders are subject to many business constraints. And here I've listened the most important ones. So first, you have to consider the pack size, because from the warehouse, sometimes you cannot ship single items, you need to ship packs. You have to keep in mind that the storage capacity in stores, at least in some stores, is quite limited, and you cannot send too large orders to some stores. You have to keep track whether you have enough transport capacity to carry all the store orders. And you have to make sure that there are workers available in the stores that can unload your orders. So a lot of business constraints, and we to solve those such a problem, we use standard operational research techniques. We use the optimization techniques that are available in SaaSVia. So also here is an advantage that everything is inside SaaS. Even for inventory optimization, you don't need to leave the environment. You calculate everything in SaaS inside the same environment. And as I already mentioned, the process we have implemented at Rossmann is a very operational process. It has extensive monitoring capabilities. We have delivered them to the customer. We have a lot of alerts that analyze, look out for potential problems, be they technical, like for example, some missing data, or some business problems, like, okay, if you don't ship fast and large order to that store, you might have a large number of stockouts there. So also we generate business alerts. And all those alerts are technically published to the Rossmann message bus, and we use this message bus to interface with the front-end applications. So we don't provide those front-end applications, though those are provided by the customer, and we use a message bus to interface with those applications. This is for replenishment and forecasting system. It's really important to monitor the forecast quality, and we have a set of reports that are used to automatically monitor the forecast stability and quality. What metric do we use? Let's say that we use weighted MAP. That is the most popular metric used by business for forecast assessment. And we evaluate it both at the store level and at the article level. However, we do not evaluate it at the store and article level, because a lot of items are really slow moving items, so with sales like a few items per month. And for those items, it doesn't make much sense to use weighted MAP. Regarding results, we cannot discuss in public detailed results. However, I can say that the forecast accuracy is really good, and most groups have a forecast accuracy over 80%. Of course, it depends on the category. Some categories like pet food or shaving items are quite easy to model. They have really high forecast accuracy, approaching close to 90%. However, some categories like umbrellas have really lousy forecast accuracy, but obviously we don't include weather information in our forecast, and that would be the most probably important driver of sales for that category. I would like also to say a few words how we handle the COVID situation, because, well, this system is live, it's operating, and we were hit by COVID, and actually it was a pretty bad hit. First, what we have seen, it was a huge demand increase in all those popular category items. So all the hand sanitizers, soap, it flew from the shelves. People were crazy for toilet paper. Probably this was also in hot items in your country. So a lot of the sales, we emptied very soon the warehouse. Suppliers couldn't deliver new shipments. So first, a lot of quite difficult time related to huge demand, and as the country locked down, because we locked down quite fast, quite soon, and quite hard, we have seen a really crash in demand. The larger stores, those at big shopping centers, were hit the hardest, because those people were afraid to go there. The smaller stores, some of the smaller stores even increased daily sales in that time. However, what we also observed was a quite drastic change in demand patterns. So, for example, people started just to buy the essential items, so nobody really bought makeup or perfume. So that was the situation after the demand increase, a quite severe lowering of the sales. So what we did to improve the situations? First, we tried to model for COVID. As the situation developed, we added several dummy variables that were used to model the structural change. We also, for some of the categories, we have shortened the model history that is used, the history horizon that is used to estimate the models. But this was not enough. For some items, it was necessary to use overrides. And also the request of the customer, we change the product allocation rules. So for example, if before COVID, if a product was not available in sufficient quantity for all stores, then only the stores with the highest turnover would receive the stores. But during the COVID situation, Rossmann wanted to spread out the sales over all the stores, so we changed the allocation rules, and all the stores receive a little of the shortage items. Now, a few words about the technical side of the project. As I already said, it was implemented in SaaS using our via platform. The platform is cloud enabled. However, the customer preferred an on-premise installation. So this is how the software was installed at Rossmann. We have 3 environments: development, test, and production. And each of one has quite a beefy specification, because we use for everyone 8 servers with quite large number of cores and memory. And so overall, this is a pretty large setup, and this allows for really good runtimes. We can run the complete operational process in under 2 hours. So I would say this is pretty nice for such a complex system, where you need to generate 20 millions of forecasts day by day, and generate replenishment orders for up to 600 stores. So that would complete my presentation. So I would gladly answer any questions you might have.
Thank you, Michał, for the presentation. We have 4 questions of Slido, so we might answer them all, but I would ask you to answer them like quickly. The first one is, why is the explainability of machine learning models so important here? Does Rossmann want to double check the models, or is it because they want to learn from that?
It's because of the second reason. So we use it's not as important as when you developed risk scoring model, that type of models. However, they try always to use them to learn from the models. So it's simply somewhat more difficult when you use those techniques instead of, let's say, the standard approach.
Okay. Second question is, did Rossmann implemented methods from its Kaggle competition? Did you compare your solution to Kaggle winners? Just for the ones that haven't checked the link, the Kaggle competition is from 2015. So
yeah, I know. So this is obviously we are aware of the Kaggle competition. However, this is a different Rossmann. So this was for Rossmann in Germany, and of course we looked at the results. However, this is Rossmann Poland is an independent operation with an independent IT setup. So we didn't cross-check the results in any way.
Okay.
I think also that as far I'm aware, Rossmann in Germany didn't really implement any of those techniques that were developed during that Kaggle exercise.
Yeah, shame. What technique did you use to find a proxy product for a new product, distance in feature space, or did you use some embedding techniques?
No, we use a quite simple and standard approach, that is distance in feature space.
Okay. The next question is, how do you deal with the short time series and new products? I guess you answered because the question appeared before the slide.
Yeah, we try to find, because it might happen that because we need to provide forecast with a horizon of 4 months. So you might have you need to provide forecasts for items which you have any sales. So the sales will have some history in a few weeks, or if it's at the end of the horizon after some months. So the only information you have about the product are the metadata. So product attributes, prices, where in the hierarchy it's located, where there are any planned promotion, and so on. So we use simply those information to find a proxy product, and use an existing product and use the forecast of the existing product to generate the forecast for the new product. Of course, we allow for some expert overrides, some parameter tuning, and so on.
Okay, and the last question, what was the optimization function in respect of replenishment orders, lower cost, higher sale, or profit?
So it's higher sale or even higher profit, because the direct, what we minimize during the replenishment, when we solve the replenishment problem, we minimize the number of so-called stockouts. And so we minimize we optimize for higher sale. However, there is a priority related to every article, and the priority is also related to the profit margin of any item, of that item. So it's a mixed approach. Okay. Sales and profits.
So thank you very much for all the answers. Thank you very much for the presentation. It was, at least for me, very, very interesting. If I'm not mistaken, Michał should be also available for the group speed dating. So if you're lucky, he can be in your group and you can ask him more questions. And now I would like to introduce our second speaker, Tatiana. She worked at DHL. And she is very interested in natural language processing, and she will tell us more about how they use natural language processing to make DHL more efficient. So Tatiana, the virtual floor is yours.
Thank you, Ivan. Hello, everyone. So I'm Tatiana from Digital Lab in DHL, and today I would like to tell you about the ways how we deal with free unstructured text in the company. And to motivate the topic, I would like to say that every day there are millions of free unstructured text generated in the company. And those texts can be emails, chat conversations, those can be description of the products on their way, or, for example, description of incidents which are happening in data center, let's say. Also, those texts are generated by a number of surveys conducted in the company, which are distributed between the employees. And that was the reason why we created the tool, which would allow to process free unstructured text more efficiently and faster than the human would process it. And the tool I'm talking about and presenting today is called Topicon, which stands for topic plus icon. And its main goal is to cluster the text and define the main topics in the free unstructured text. Today, I will be presenting the functionality of Topicon based on the data that we've got from Employee Opinion Survey. Employee Opinion Survey, this is the regular survey conducted within DHL, and its goal is to understand how people feel in the company, what they like, what they don't like, what should be improved. And the survey includes both structured questions where the respondent has to choose the answer on the scale. And what is the most relevant to our today topic is that there are two open text questions, and those are what is working well and what needs to be improved. And employees are free to write anything there. And we also have EOS teams, Employee Opinion Survey teams, whose task is to analyze those open comments. And with our tool, we are trying to help them do it better and faster. In general, the survey is conducted in many locations, in different departments and business units. And for this particular presentation and example, we have chosen data set from IT services in different locations, and it includes around 5,000 of free comments. In this slide, you can see the general overview of the tool, how it looks like and what everything it can offer. In general, the tool provides interactive visualization, which is HTML page, and I will show you the page in details a bit later, but just for you to understand how it looks like. So let's say on the top left corner of the tool, you can see the 2D projection of clusters or topic that we found. On the right-hand side, you can see the word clouds for each cluster. So on the one hand, you have the very general overview of the main topics discussed in the survey. On the other hand, you can see not just the topic itself, but dig a bit deeper, looking at the word clouds. And the last important output is also on the bottom, is the original data set with original comments, which are tagged with the cluster, which they belong to, and ordered by the cluster. So if the user wants to dig even deeper, to go through the comments, the added value is that the comments are already grouped by the cluster and ordered, so he can easier get oriented in the topic. Also, I would like to mention that Topicon, the tool, is in development. We tend to constantly add new features to implement state-of-the-art NLP technologies to improve its functionality. The result that you see on the screen is one of the later versions, meaning that not all functionalities are included here because some of those are still in development and in testing phase. But in this presentation, I would go through all stages or modules which the tool includes so that you can have the idea what is already or will soon be possible to do with Topicon. Here is the short overview of the main modules or the main stages which are provided within the tool. So the first one is text preprocessing, then text vectorization, sentiment analysis, text clustering, and visualization. And now I would like to go through all those stages one by one in more details. So first, we are getting the text. And the very first step is to pre-process, to clean the text. And in this case, in general, I must say that the tool is programmed in Python, and we are utilizing already available libraries which were developed for natural language processing, like GenSim and NLTK. And specifically, the functionalities from those libraries are used to pre-process, to do the basic pre-processing of the comments, which is turn it into lowercase, apply stemming, lemmatization. We also exclude stop words. Those can be default language stop words, English or German or any other language. And we also are trying to exclude the context, like stop words. At the moment, once I'm talking about context, like stop words, this is iterative process, meaning that we are getting some output, we show it to specific department or the customer who wants to use it, and we are getting feedback in terms of which other words could be included, excluded, and so on. Though we have some ideas how to improve the process, and I will be talking about it later. So now we have cleaned and pre-processed the text, and the next stage is to turn the text into numbers. And here we are using multiple techniques. We have tested quite a few of those. Some of those work better. Some of those still have to be tuned. The techniques used are count vectorizer. It's a standard, relatively standard way, or like the basic way how to turn the text into numbers. On the right lower corner, you can see example how it turns the text into numbers. We used TF-IDF, and one of the recent advances that we used and implemented is the doc-to-vec modeling, when we turn the comments into vectors. And the doc-to-vec model is basically, like, the architecture of the model is basically the same as the word-to-vec, with the exception that the feature vector for specific document, like paragraph ID, is added. And once word-to-vec model is trained, we are also getting the numeric representation for the document, for the comment itself. So this is the way how we turn text into numbers. Next step is the sentiment analysis. I have already mentioned that the survey we are analyzing already includes two questions. One is what is working well, another one what needs to be improved. So on the one hand, we could say that the comments are already separated into positive and negative ones. However, as you may expect, once answering the question what is working well, the person can write, in general, I like everything, however, I would improve, or something is not really working well. So it's questionable whether the comment is actually positive or negative. So we decided to apply sentiment prediction to every comment. And if, for example, the sentiment is negative and we see that the comment actually belongs to the group what is working well, we move it to the group what needs to be improved. And for sentiment analysis, we used a state-of-the-art NLP model, which is BERT, bidirectional encoder representations from transformers. And what is special about BERT is that, in general, once BERT model is trained, it's trained to predict the randomly masked words in the comments, in the sentences. And after being trained, it represents the specific patterns and dependencies in the language itself. So it provides so-called language model. And language model, what is it technically? It's basically the network, neural network with trained weights. And what we've done, we took this network with pre-trained weights, And as the last layer, we added the classification layer, which actually does the sentiment prediction, which returns the value of the sentiment. And then we used additional data that I will be talking about a bit later and passed it through this architecture to fine-tune the model, to fine-tune the weights of the model and to predict the value of the sentiment. To fine-tune the model, we have used publicly available data sets with labeled sentiment and also some DHL-specific data from our chat conversation, which were rated with some sentiment-like values and from responses to how certain incident was solved within the DHL. So once we fine-tuned the sentiment prediction model, it was able to understand DHL-specific terminology and way of communication better. So this is the sentiment prediction stage. Now, once we have the comments pre-processed, split into positive and negative, we would like to understand what actually is working well, what is not working well separately. And so we want to get the main topics that people are talking about. And the way how we do it, we apply clustering techniques. We tried quite a few clustering methods, and the one that worked the best for us so far was the hierarchical clustering. We have also tried latent Dirichlet allocation, and this is the methodology I will be talking about a bit later as well. In general, I must say that hierarchical clustering returned better results in terms of homogeneity of individual clusters. And the reason could be that, let's say, with latent Dirichlet allocation, we are getting the distribution of topics or the comment. So let's say we have some comment which has 45% of one topic and 55% of another one. So even for human, it could be a bit difficult to really say whether it's topic 1 or topic 2 or maybe the third one. So the clusters that we've got with LDA were somewhat mixed, and we have some ideas how to actually use LDA, but again, a bit later about that. So now we clustered our topics. Also, I would like to add here one point that we, within the tool, we also have the functionality which allows you to find the optimal number of clusters automatically. However, based on our experience, we've seen that usually this functionality suggests too many clusters, like tens of clusters. And it might be difficult for the human eye to process it easily. So at the moment, what we are doing, we are rather defining the best number of clusters, again, iteratively with the customer or with the user to find what suits him the best. Once we defined the clusters, once we tagged each comment with specific label, we have decided to visualize how it looks like and to visualize the clusters in a way so that we could preserve the relation between clusters. So we used for that 2D projection methodology, specific multidimensional scaling, which allowed us to project the clusters into 2D. And it's projected so that, let's say, if two clusters are close to each other, how we would interpret it is that it means that they are related to similar issue. However, people are talking about this issue from different perspectives. So the clusters are closer to each other, and it can bring extra insights once we interpret the results. In general, for the visualization, we used Bokeh to provide interactivity and flexibility of the outputs. Now I would like to show you how the output actually looks like. I will switch to a specific example. This is the one that you've seen in one of the slides. So as I have mentioned already, the EOS survey is conducted in different locations. And so in the visualization, we have a separate tab for each location. You can see Prague, Azerbaijan, Germany, Americas, Chennai. And as well, we have the tab for each question separately, because it doesn't make sense to mix those positive and negative comments. So you can see the results. And on the left-hand side, again, we have 2D projection of the clusters. We have the topic of the cluster. And what's the topic? The topic is two most frequent words or phrases which appear in the comments within the cluster. Once you hover over the cluster, you can see so-called central comment. And this is the comment which has the smallest distance with respect to other comments in the same cluster. Also, we have edges between the cluster pairs. And if you hover over the edge, you can see two comments which belong to each of those clusters, which have the smallest distance between them as well. It can give some extra insights and details into the results. Okay. Also, as I was already, I'm not sure whether you can see this. Okay. As I was already mentioning, we have the original data set where all comments are grouped into clusters tagged with specific color, which corresponds to the topic. And so if needed, the person can go through and read and check whether it makes sense how the documents were clustered. Also, what else we have? Here you can see the simple bar chart, which shows the number of comments per cluster, and the size of the comment is proportional to the number of comments in the cluster. Here you can see that we have some smaller clusters, and usually we see that they're quite homogeneous. So they really belong together, the comments in this cluster. However, we also are getting one large cluster, and once we go through this large cluster, we can see that the comments are somewhat ambiguous. So it was difficult for the algorithm to really decide which other cluster it should belong to. And I must say this is the issue we are facing at the moment, and we are trying to deal with that, applying different NLP technologies. For example, this particular example, it's the clustering where the input is done by count vectorizer, where the vectorization is done by count vectorizer. If we apply doc2vec, here I can show you another example. If we apply doc2vec to vectorize our comments, we are getting somewhat better results in terms of how the comments are split proportionally between the clusters. And still, I must say that we are working on the homogeneity of the clusters at the moment, but the results look promising. So we keep working on that to separate as many comments as possible into the topics. Okay, so this is how the results look like. Also, once we provide the visual interpretation, visual result of our tool, we tend to help the customer to interpret the results. And here I provide you some example of our interpretation where we tried to be a bit creative. So this one is for ITS in Prague, and for the question, tell us what is working well. So if we look at the clusters which were defined, we could separate it into 4 principles or 4 parts. For example, on the east, this part, we can see the clusters like training opportunity and coffee machine. So we would say that what is working well? What is working well is that people are getting what they need, like some basic needs to make a good working day. So they need coffee, they need some opportunities, training opportunities. So this is the eastern part of this 2D projection. Then we can also look at the north. Here we can see knowledge sharing and training opportunities. So it means that what is working well is to know what is useful for efficient work. So to be efficient, to continuously improve ourselves, we need to have training opportunities in the company, and we need to have efficient knowledge and experience sharing between the employees and team members. What we see on the west, here we have quite a few clusters stacked together, but it's logical because one of the keywords in those clusters are cooperation, communication, and all of this is circulated around the customer support. So it means that people, they do purposeful things, meaning supporting the customer together, so they cooperate, communicate. Then we also separate the south part, this one, and here you can see the clusters like working environment, working cooperation, and we added here also teamwork and spirit, which represent rather soft skills, the ability to be friendly, respectful, and open-minded. So this is one of the examples how we tried to help with the result interpretations. Also, as I've mentioned, we are using doc2vec model to get the numeric representation of the comments. And one of the side outputs of these are the vectors with which we can play and analyze further. And for example, we could look for the closest or the most similar comments and words in our corpus. And this is, on the one hand, it can provide useful results or some useful insights. On the other hand, it can give us some impression on whether the model is trained reasonably, whether it provides really reasonable results. You can have a look at it in more details. Due to some time limits, I would draw your attention, for example, to this one. I like this one. The target comment was equality among all employees, and the most similar comment to that in the whole corpus was equality within the hierarchy. So it's the same thing said in different words. Also, we tried to have a look at the most similar words in the corpus. So for example, if we take the target word heart, the most similar one is sincerity, which is logical. The target word ownership, most similar one, accountability. For the tolerance, we have patience. They're almost synonymous. For opinion, we have intelligence. And the last points I would like to mention are the next steps, how we could improve the results and user experience. And here I would describe the very next steps which we see and would like to undertake. Regarding data preparation, we've seen in a number of comments that people tend to write about several topics at once. And at the moment, we still treat this comment as one. However, it would be beneficial definitely for the algorithm to separate it. So we would like to predict the topic within the comment itself and separate it. So to split it into as many topics as many are discussed within the comment. This is one way. Also, the extra stop words definition. This is idea from my colleague Andrei Pluskal. So he suggested that once we have the BERT model trained, meaning that we have the sentiment prediction model, we could have a look at the attention layer and extract the words which have the highest impact into sentiment prediction. So this way we would get the words which really describe the sentiment of the sentence. And we could exclude them, because what we need is not sentiment, since we already know whether it's positive or negative, but we need the neutral description of the topic itself. What is the core of the sentence, of the comment. So regarding clustering, as I was mentioning, the LDA didn't provide reasonably good clustering results. So we are thinking to use LDA not for the clustering itself, but rather to use it as comments representation, numerical representation of the comments, which in turn can be input to the clustering. Also, at the moment, we used multidimensional scaling to project the clusters into 2D. We would like to use more advanced techniques like Disney or UMAP. And the last one is the user experience. One of our relatively ambitious ideas is to provide the summary for the cluster. So once you hover over the cluster, you could see the summary of the comments which belong to the cluster, and ideally abstracted summary. And also what we would like to have is the interactive split into subclusters. Since we are using hierarchical clustering, we could utilize the information from the hierarchical clustering, for example, having the biggest one split into the next two, and so on and so forth. It could be also could bring useful insights and values for the user. And that's it from my side. Thank you everyone for attention. And if you have any questions, I would like to answer.
I think that in the name of all, thank you very much for your talk. And yes, there are at least 3 questions. So let's start with the top one. If you use BERT, do you really need lemmatization, cleaning of stop words? Couldn't you just use BERT embeddings instead of word2vec or doc2vec?
Okay, so for the BERT, we use the language representation based on the BERT pre-trained model. So what we input to fine-tune is the pre-processed, at the moment it's the pre-processed data set, but we can experiment. I think we can experiment to exclude the lemmatization and cleaning the stop words. And couldn't you just use BERT embedding instead of word2vec, doc2vec? But again, I think we used the language representation, the pre-trained network itself, which we tuned afterwards. We think that in this case, we still need to do the numerical representation of the individual comments. But we can discuss it later on.
Yeah. So if anyone have the person that wrote this question can discuss it with Tatiana probably in bigger details in the meeting rooms. Let's go to the question number 2. Do you use method for various languages, or do you use only for Czech, English, and so on?
At the moment, we translated all comments into English to have it unified.
Okay, so then it's obvious. And the last question is, in the plot of clusters, how do you decide the position of the circle representing the cluster?
The position is returned as output of multidimensional scaling. So we are getting the coordinates of the center of the cluster.
Okay. Thank you. Once again, thank you very much for all the answers. First of all, thank both speakers for very interesting lectures. Thanks all the attendees. And I think at this moment, the organizers will start the speed dating groups. So let's maybe wait 1 minute.